Hi guys, welcome back to our series of discussion about statics of rigid bodies. In today's discussion, we shall be discussing couples, the definitions of couples, as well as its properties. On the later part of this discussion, I have prepared a sample problem that will show how the properties of couple can be used in solving engineering problems. So let's start with the definition of a couple. According to some authors of the books, couple is defined as a pair of equal, parallel, non-collinear, oppositely directed forces. So when we have a pair of forces as shown in this illustration, for example, we have here a force that is directed downward, and somewhere here I have another force that is directed downward, in which their directions are a parallel. They are equal in magnitude, and they are oppositely directed. Then we call this as a couple. In a couple, there is a perpendicular distance between them, and this is called as the moment arm of a couple. So in the illustration, this distance that shows the perpendicular distance between the two forces, that is what we call the moment arm. Since couple consists of a pair of equal and oppositely directed forces, then the couple has no translational effect. Why? Because the summation or the resultant of all the forces in any direction shall be equal to 0, and therefore there will be no translational effect because resultant is equal to 0. However, the only effect of a couple is a tendency to rotate the body about any axis perpendicular to the plane of the couple. Though the resultant is 0, there is still an effect. The effect of the couple is to cause rotation, about an axis that is perpendicular to the plane that contains the couple. And the moment sum of its forces is constant. That is one unique property of a couple. The moment sum of its forces is constant and is independent of any moment center. And that moment sum is equal to the product of the magnitude of the force and the moment arm, or the distance between the two forces. So in this example, to explain this unique property of the couple, let us have this explanation. Let us have that there is a point A somewhere to the left of this first force, and the distance of that A from that force is defined as x sub 1. If we will be summing up all those moments of the forces, or these two parallel forces about A, considering that one direction is positive, if we will be using the right hand thumb rule in defining a positive moment, then we will be using the moment in the counterclockwise direction as positive. Then we shall be having a moment summation equal to the moment due to this F will be negative because it will be producing a clockwise moment, and that is equal to the product of the force multiplied by the perpendicular distance of that force from point A. This force will create a counterclockwise moment about A, and therefore the moment produced will be equal to positive, and that is equal to positive, or plus F multiplied the moment arm, which is the sum of x sub 1 plus d. This is x sub 1 plus d. Now, if this equation will be simplified, then we shall have the summation of moment about A equal to negative f times x sub 1 plus f times x sub 1 plus f times t. And you will notice that these two f times x sub 1 will just cancel each other, and what will remain is that the summation of moment about A will be equal to the product of f multiplied by the distance d. Suppose that we selected another point P, and we take the same summation of moment of these two forces about B. What are we going to have? If we will sum up all those moments about B, and considering the same direction, that counterclockwise moment, considering or using the right hand thumb principle, B equal to a positive moment, then we shall have the summation equal to the product of F multiplied the moment arm. of 0 because f just passes through point B, and that is equal to f multiplied by 0. While this force will create a rotation in the counterclockwise moment, hence that would produce a positive moment equal to f multiplied by d. And then simplifying this equation, this would become equal to the product of f multiplied by d. You will notice that in our first example, when we take the summation of moment about point A, which is somewhere to the left of point of f, and another point at B, which is directly along the direction of f, we obtain the same value of the moment equal to the product of f multiplied by d. Say for example, we take another point, and this time we consider another point G somewhere to the right of the rightmost directed force F. And assuming that this G has a distance equal to x sub 2 from this force, then what shall be the summation of moment of all these two forces about G? If we will be using the same convention that counterclockwise moment as positive, then we will be getting the moment due to this force, which will be counterclockwise about G, hence positive equal to the product of F multiplied by the moment arm of this F from G, and that is the sum of D and x sub 2. Okay, while this one will be producing a clockwise moment, hence that would be a negative F multiplied by its moment arm x sub 2. And when we simplify this term, we shall be getting that the moment of the forces about G shall be the product of F multiplied by D plus F multiplied by x sub 2 minus F multiplied by x sub 2. And again, you will notice that these two F times x sub 2 will cancel each other. Hence, we shall be getting the summation of moment about G equal to the product of F multiplied by G. So this is an example, explanation of that property of the couple, such that the couple has a moment sum equal to a constant, which is equal to the product of the force multiplied by the moment arm between the two forces. And this is independent of any moment center, meaning you can take the summation of moment and you'll be getting the same value as the product of F multiplied by D. So since the effect of the couple is just to produce a moment arm that is independent of the moment center, then we would expect that the effect of the couple is unchanged if the couple is rotated through any angle in this plane. Ang sabi daw dito, kapag ang couple daw ay in-rotate at any angle in the same plane, then the effect of the couple will not be changed. To illustrate this explanation, this concept about why couple what will happen to the effect of the couple, this is how it will be explained. Imagine that we have here on the plane, and on the plane there acts a couple, pair of force parallel in a direction, oppositely directed, and having the same magnitude. Then this couple will have a magnitude of the product of F multiplied by D and will cause a rotation in the counterclockwise moment. We say that the couple will not be changed if this couple will be rotated through any angle in its plane. Say for example that we try to rotate this couple such that the couple becomes in this placed in this direction. The direction of F is somewhat inclined at a certain angle with respect to the horizontal. Will the effect of the couple change? According to the discussion, the effect of the couple will be unchanged. It will remain equal to the product of F multiplied by D and with the same sense as counterclockwise in direction. Even if the couple is rotated in this direction, the magnitude will be the same, the sense or direction will still be the same. That's how we explain the property of the couple, that it will be not changed when the couple is rotated through any angle in its plane. What about the other one? Say, it is said here that the effect of the couple will not be changed if the couple is shifted to another position in its plane. Sabi naman dito, kapag daw yung couple inlipat natin on another position on the same plane, then the effect of the couple will not be changed. Halimbawa, we have here a couple. Again, this couple will be having a magnitude equal to the product of F multiplied by D, and it will cause a rotation in the counterclockwise direction. If this couple is shifted to another position, okay, from the center to somewhere at the left, the effect of the couple will not be changed. It will remain as the product of F multiplied by D. Even if the couple is shifted in this position, then the effect of the couple will not be changed, and that it has a magnitude equal to the product of F multiplied by D. That's how we say that property of the couple. There's another property of the couple that it will not be changed if the couple is shifted to a parallel plane. Imagine that we have here a box where there are two sides that are parallel. These sides represents the plane ABC. And we expect that this plane ABC is parallel to another plane. Tawagin natin yung plane na E, F, and G. Suppose that on this box there is a couple acting in this direction. Okay, you will notice that this couple will be producing, this pair of forces will be producing a couple having a magnitude of the product equal, having a magnitude of the product of F multiplied by D. And again, it will have a sense in the direction of the counterclockwise. Now, the question is, what will happen if this couple is shifted to another plane parallel to A, B, C, and D? And what is that plane that is parallel to A, B, C, and D? You see that this E, F, G is parallel to that plane. Ibig sabihin to, if this couple is shifted to another plane, ipakita natin dito. If that is shifted there, okay? Nakita natin, i-shift natin itong F couple doon sa kabilang side. What will happen? According to the discussion, the effect of the couple will not be changed. It will remain the product of F multiplied by the distance between them and will produce a counterclockwise direction as indicated in the illustration. Another property of the couple is that the couple will not be changed if the couple is replaced by another pair of forces in its plane whose product F multiplied by D and sense of rotation is unchanged. Ang sabi dito, hindi daw mababago ang epekto ng couple kapag ang couple ay pinalitan ng another pair as long as the product F multiplied by D remains the same and the sense or directions of the couple is the same as the direction of the original couple. Anong ibig sabihin yan? To explain that, let us have here a body. And this body is subjected to this couple. A pair of 100 Newton oppositely directed, parallel in direction. And these two forces are separated by a 2-meter distance. Hence, this pair of forces will produce a couple equal to 200 Newton meter. What will happen if this pair is replaced by another pair of couples or pair of forces such that we have this having 50 Newton force acting at a distance of 4 meters. Since the product of 50 multiplied by 4 remains the same as 200, then the effect of the previous couple will be the same as the effect of this couple. Or if we change this with a larger force placed at a closer distance such that you have 200 acting at 1 meter distance, then the effect will be the same. Or even if we change it with another pair, 40 having a distance of 5, the effect will not be changed. And that's how we explain that property of the couple, that the couple will not be changed if the couple is replaced by another pair as long as the product F multiplied by D and the sense is not changed. Now let's move to the other topic about the couple. And this is about the resolution of force into a force and a couple. Anong ibig sabihin to? We try, force is resolved into a force and a couple. Bakit ba nangyayaring ganyan? Here is the explanation. Sometimes it is necessary that a force acting on one position be moved to another position. Common yun eh. It's very common that if you have a force acting on one position, sometimes there is a need for us to change the position of that force. What will happen when that force is moved from one position to another? Here, sabi dito, although the translational effect of the force might not change because you just have placed the position from one position to another. However, it may cause rotational effect due to the change in the position of the force acting on the body. Though the translational effect might not be changed, but because the body or the force is moved from one position to another, it will cause rotational effect. When that happens, then the force is resolved into a force and a couple. Ganun yun. Okay, to illustrate the concept, here is how this can be illustrated. Imagine that we have here a block, and on the block there is a point where a force F is acting. Suppose that on this force, on this block, we add a pair of a pair of collinear and oppositely directed forces whose magnitudes are the same. Say for example, I have here added from a point D to this F a pair of oppositely directed collinear forces and equal in magnitude, and here is the force. You will notice that if I add these forces, nothing will change. Why? Because I simply have added an equilibrium. The resultant of these two forces is just equal to 0. So when I added 0 to the system, nothing will change to the original system. However, if I add this pair of forces, you will notice that these two forces will now constitute a couple. One directed downward, the other one directed upward, and they are parallel in action, separated by a distance d. Therefore, this pair of forces constitutes now a couple having a magnitude of the product of F and the distance between them. Hence, if these two forces will be replaced by this couple, what will remain on the system? Then the system will have this effect. And you will notice that the original force that was acting before is now replaced with a pair of a force and a couple. The effect of this upon the body is also the same as the effect of this system upon the body. However, when doing so, we have replaced this force into a pair of a force and a couple. And this is how we resolve a force into a force and a couple. Okay? Now, let us have this as an example. This example actually is taken from the book of Ferdinand Singer, Engineering Mechanics, on page 69. The problem is 2-13.5. And the problem states that replace the system of forces acting on the frame in the figure by a resultant force R through A and a couple acting horizontally through B and C. The illustration is shown in this manner. There is a bar whose dimensions are given 1 foot, 3 feet here, there, 4 feet dito, and then there is 3 feet there. There are points A here and another points B there and point C there. This bar is subjected to the following external forces. 20 pounds to the left of A. There is another force acting here having a magnitude of 30 pounds and another force acting here having a magnitude of 60 pounds and directed downward. According to the problem, we will be replacing this system of forces by a resultant that is acting through A and a couple acting horizontally through B and C. Papalitan daw natin ito, tatlong forces na ito, ng isang force na nag-act dito sa A at ng couple na nag-act naman dito sa B and C. So how are we going to do it? If these two forces are moved towards A, what will happen? According to discussion, by moving the 20 and the 60-pound force from their respective positions to point A, will cause them to be resolved into a force and a couple. Just like what we have discussed earlier. If we will be moving this force from this position to that position at A, then there will be, this force will be resolved into a pair of a force and a couple. Similarly, if this force is removed from this position to that point A, then there will be a resulting force and a couple produced. And how are we going to do it? Let's find for the magnitude and the sense of the direction of the resulting couples. Okay. Now let us try to imagine that at point A, we add a pair of forces that are collinear in action. The magnitude are both equal to 20. Imagine daw natin na at this point, magdagdag tayo ng dalawang forces na equal ang magnitude, collinear in action, and opposite in direction. Ano ngayon ang idinaragdag natin? We will be actually adding an equilibrium. Let us show it this way. Pakita natin itong inad natin ito. Itong nagbiblink na forces na ito ay equilibrium. At pag nagdagdag tayo ng equilibrium, okay, nothing actually is changed to the effect of the original system because what we just have added is a force system whose resultant is 0. However, okay, in doing so, you will notice that this pair of forces will now constitute a couple, having a magnitude of 20 multiplied by 1 and directed in the counterclockwise direction. Therefore, it will be producing a couple having a magnitude of 20 foot-pounds in the counterclockwise direction. Hence, we can replace this pair of forces by this one. So after we have added this force, then we can now remove the two forces. What happened now? Okay, we have now shifted the original position of 20 from this point to this point. However, there is an additional couple produced having a magnitude of 20 foot-pound. Now let us try to do the same. Now look at this 60. If we will be adding a pair of forces at point A, whose magnitude is also are equal to 60, the directions are opposite and they are collinear. Imagine natin that we have here added 60 that is downward and another force 60 that is upward. Actually, when we add this pair of forces, we have just added nothing because the effect of these two forces is just equal to 0. However, when we added those forces, makikita natin that this pair of forces, itong nako-cover, itong yellow shaded parallelogram, actually constitute a couple. A couple having a magnitude equal to 240 foot-pounds and directed in the clockwise direction. So if we will be replacing this pair by that, then we can now remove this pair of forces, and what we will now have, okay, is a couple in the clockwise direction. Now after transferring these two forces, you will notice that all the three forces now are acting through A. And from there, we can already take the resultant of the forces. So if we will be getting the resultant of the forces, since the resultant are just the summation of the forces, when we take the force directed upward as positive, then we shall have the resultant equal to this one is downward, therefore that is negative. Okay, this one is upward, therefore that is positive, and the other one 60 is downward, therefore that is also negative. And when we simplify, we shall have here a resultant that is negative 50. Itong negative na ito tumutukoy that the direction is opposite what we have used as our convention. Since we have used a convention equal to positive when it is upward, and because the result is negative, therefore we can say that the resultant is 50 and directed downward. Similarly, we can solve for the resulting couple, and the resulting couple is just the summations of the couples produced when all the forces are transferred from their original position to that of point A. And we have here, and when we assume that the direction using the right hand thumb principle be positive, such that counterclockwise positive, then 20 will be positive while 240 will be negative, such that we shall have here 20 minus 240, and that the result is equal to negative 220. I'll explain the meaning of this negative. The meaning of negative is that, okay, the direction of the resulting couple is opposite the convention that we have. Since our convention is counterclockwise as positive, it follows therefore that the resulting couple is 220 and opposite of that convention, and therefore it is clockwise in this direction. Now what will happen? Since in the problem is that we shall be determining what are the magnitudes of those forces that will be acting through B and C, so that it will, okay, have the same effect as that of the couple. In my discussion earlier, okay, one of the property of the couple is that the effect of the couple is not changed if the couple is replaced by another pair of forces such that the product F multiplied by D is the same, as well as the sense. Now, looking back at this resulting couple, the resulting couple is 220, and we wanted that this couple be replaced by a pair of forces acting, okay, through B and C. Then we should expect that, okay, there will be horizontal forces acting B and C, and to produce clockwise moment, then we would expect that, okay, the force acting at B should be towards the right, while the direction of the force acting through C must be directed to the left. And to find for the magnitude, okay, sabi diyan, the magnitude of the couple shall be equal to the difference between the resulting couple and the distance between them, and that you shall have here, okay, an F equal to 110 pounds. It follows therefore that if the direction of the couple is clockwise, then the pair of forces must also produce clockwise direction. Hence, the force 110 pound must be directed to the right at B, and the 110 pound force must be directed to the left at C. So that the equivalent force system shall be shown as follows. So, if this is the original system that is subjected to the different forces at different position, after, okay, solving the problem, okay, this system can now be replaced by a force acting through A, which is 50 downward, and a couple, okay, through B and C having a magnitude of 110, such that this magnitude shall be equal to 220. So that's how we explain, okay, the meaning of the couple and have shown the application of the different properties in solving some problems in engineering mechanics or statics of rigid bodies. I hope that you are able to follow the discussion, and in the future you shall be able to use, okay, the application that I have just presented in solving another problems in statics of rigid bodies. Again, thank you for watching.